Did the program you're running just disappear? Let me show you some common reasons why programs just disappear. Alright, let's see that again. Let me switch to my remote machine. So what I have here is a program that I wrote to illustrate the problem of a program just disappearing when it has a problem. I have two buttons on the screen, Start Infinite and Start Buffer Overflow. When I click any of the two buttons, the program will disappear. I'm going to click Start Buffer Overflow and you will see after a couple of seconds, the program will just disappear off the screen. There we are. The program is now gone. The root cause is that the program crashed without triggering the Windows error message dialog. This can sometimes happen and the program just disappears, but I'll show you some techniques how to diagnose this problem and how to use windbg to find the root cause of what's going on. Okay, let's go back and run the application again, but this time I'm going to run it within windbg. I'm going to use the x86 version of windbg. Any version of windbg will do. I just had this one handy. So I'm just going to open the executable over here. Let me just put the path to the executable. So I'm going to run the executable through windbg. And the first thing I get is I get the initial breakpoint over here. I'm just going to leave it for now. Initial breakpoint means nothing. I'm just going to press F5 and that's going to run the program. And there we are, the program is running. Okay, so the first thing I'm going to do is I'm going to hit the Start Infinite button and you're going to see that the program is going to go into a recursive infinity loop and then it's going to crash. So let me just click the button. There we are. Every time it recurses, it's going to write a line called going infinite. I will put the source code of this program in the link below so that you can give it a try as well. There's nothing special about this program. It is just that I've written this program to be as simple as possible to illustrate the problem of a disappearing program. Now, if we take a look at windbg, it has stopped on a first chance exception. Now, windbg, when it is attached to a process, will get all exceptions before the process does. So even though there is an exception, windbg actually captures the exception first before it goes to the process. Now, if this does not happen for your instance of windbg, just check the exception list with SX to see whether it is handling all exceptions. Usually, the default value for SX will work. If you're unsure what is the settings for your windbg, just type SXR and this will reset all the exceptions and it will surely stop when you get the next exception. Now, at this point, I can capture a memory dump and I can do analysis, but just to keep this video short, what I'm going to do is I'm just going to type analyze -v over here and the analysis will run. It's going to be the same as analyzing a memory dump, just that when you are running analyze -v on an executable, it's going to be a bit slower because of the way it has to unwind the memory and all these things. Just be patient. I'll fast forward this video to the end of the analysis. So my computer is not really that fast, but I'll just skip the analysis so that you get to see the output. Okay, windbg has completed running analyze -v. Let's just take a look at the results. So the failure bucket ID is Stack Overflow. That's correct. Let's scroll up to the stack and we can see that the stack over here, the stack text, it has overflowed because it's basically a recursive function called onStartInfinite. Now it says here a new guard page for the stack cannot be created. What that means is that there is something that protects the stack from overflowing. How it works is as follows. The stack represented here in this table has got a magic number inserted into it. This value, the canary, is inserted adjacent to the values that would be the ESP and the EBP registers. The canary is known as the guard stack in Visual Studio. Different compilers have different positions for the canary, so this table is just an approximation. This canary is controlled via the /GS option in Visual Studio. There are numerous calling conventions, so the positions can be different. The canary is checked when a function reaches the end of a function call. The ret assembler instruction only executes correctly if the canary value is unchanged. The ret assembler instruction is the return of the function. This is how a guard stack works. If a variable overflows, the canary value changes. Thus, this function cannot return without throwing an exception. So, how does this work for a stack overflow? Well, basically what's happening is that because the entire stack is filled up with function calls, there is no more memory on the stack. So the canary is being read from a location which is out of bounds. This means that the ret instruction will throw an exception to indicate that the stack is corrupt. The exception raised because the stack is corrupt cannot be differentiated between a stack overflow and a buffer overflow. Corrupt just means corrupt. Even if the stack has overflowed, because the canary cannot be read, it is assumed that the stack is corrupt. Let's scroll through really quick to this analyze -v and see whether that's the case. If I scroll all the way down, yep, I can see it over here. It says stack overflow. It can deduce in a certain way because the entire stack is filled up. So it tries to deduce, but that deduction is being done by analyze -v. Truly, it cannot tell the difference between the canary being corrupted due to a buffer or the canary being corrupted due to a stack overflow. A similar exception will occur if I were to do a buffer overflow. So let's do that. Let me just run windbg again, but this time what I'll do is I'll run a buffer overflow instead. So let me just select the path for my executable over here, and I'm just gonna press F5 to run it from the initial breakpoint. There we are. So now I have my program running again. I'm just gonna click start buffer overflow, and immediately windbg actually finds that the stack cookie check has failed. Now that we have the exception, let's just run analyze -v one more time. Now, analyze is again gonna be a bit slow. So what I'm gonna do is I'm gonna cut the video and just jump to the end. Okay, the analysis is complete. Let's just review the output of analyze -v. Okay, let's review the results. So the failure bucket has a very long error message. Fail fast stack buffer overrun stack cookie check failure GS. This is the flag that Visual Studio uses. It's the guard stack. Has a false positive 0 canary seemingly intact. So what this is telling us over here, and if we read through the report over here, is that the canary value of this function has been corrupted. Now that is true because what I did for the stack overflow and for the buffer overflow was different. For the stack overflow, I just recursed the function all the way to the top, filling up the stack. But for the buffer overflow, what I did was I actually made a buffer that was too long so that it will override the bytes of the canary. So what happens is in the analysis, we actually get the canary value, which the address is here. My program is 32-bit, so that's why it's all 0 in the front. The expected canary was this number over here. I filled it up with nulls. And because of that, the canary was essentially wiped out, causing this function to actually fail. Now, this analysis for the failure of the stack actually has a dedicated command that can analyze it a bit deeper. If the canary is corrupted, but the rest of the stack is okay and it's working and it's not a stack overflow, you can actually just run GS. What GS does is that it looks at the canary and then it looks at the value that it should have, and it dumps out all the information that might help you debug which variable is causing the problem. In my case, because I wrote just one variable in the function, there's no real guess on what caused the problem. But if the stack frame is very complicated and there's a lot of variables, you can actually use the relative addresses that are output in this list over here to try to guess which variable is causing the overflow. In my case, I have a variable called myBuff, and this is what caused the overflow because this is the sequence of variables which are written on the stack. This is the assembler sequence, and by overflowing myBuff, it overflowed the canary which was next to myBuff. Also notice that the first variable is the this pointer because I use C++. So a bit of trivia, every C++ method has got a this pointer as the first variable. just in case you were trying to debug and you saw that there were no variables but yet it's stack overflowed or buffer overflowed. Yep, this is always put on the stack if it is C++. So windbg is clearly showing this is a buffer overflow. So basically, both of these errors, I intentionally wrote it to illustrate a problem. The core reason is that the exception handler that Visual Studio injects into your executables cannot always run. These kind of exceptions, the ones where the stack cannot be unwound because it's gone too far, or the buffer has overflowed, has damaged the canary so much that there cannot be a jump to the exception handler. The reason for that is that if it jumps to the exception handler, it could actually be jumping with corrupted memory, and that could be used to do a remote execution vulnerability attack on your executable. So for safety reason, the program is just wiped out of memory and there will be no handler. Now, if you have an exception in .NET or some other platform where the canary isn't corrupted, you can get a dialog that will appear to say your program is crashed. But if the canary is corrupted in these two examples, you won't get anything on the screen, the program will just disappear. Have you seen this before? Have you seen a program disappearing before? I have had to tackle this almost 100 over times. Many applications I've worked with where the program just disappears and you have no choice but to attach windbg in order to catch the exception before it disappears. Even the post-mortem handler sometimes doesn't work because the computer cannot trigger any exception handling if the canary is so corrupted that there's no way to continue. It is very annoying. The program just disappears, especially comm servers or system services. They just disappear in memory and then they get restarted at a later time. But this is the only technique that I know of in order to catch the exception before it goes to the program. If you have this exception in windbg and you resume windbg and send it to the program will disappear from memory. Anyway, gentle reminder to subscribe, hit that bell icon and give me a like if you like the content. Also, let me know in the comments below if you need any help with debugging. As always, it's been a pleasure bringing you this information. I'm High Voice, signing out.